In this work, we explore the use of computational topology in determining the next best view of a robotic manipulator on 3D point clouds. Next best view is a process of determining how a robot should look at an item after already having an initial view obtained. What is considered a good view depends on the intention for the views, the sensors used, robotic constraints, and properties of the observed object. Our method starts by generating a Viator's Rips complex on a 3D point cloud. The evolutional growth of a complex of an increasing sequence of topological spaces is called a filtration. Once a filtration is obtained, the topological Betti numbers can be derived, corresponding to the number of connected components and the number of holes in the space. The Betti values at various distances in the filtration are then algebraically combined into a single real value, representing the quality of topological features in the point cloud. Once a second view is obtained, the second point cloud is transformed and union to the initial point cloud, and a new feature value is calculated. The difference between these two feature values is then considered the reward value for deep reinforcement learning model, modeled as a multi-arm bandit problem. To obtain data, a custom 2-degree of freedom robotic manipulator was designed to allow a stereo camera to view an object from multiple directions. Non-colored point clouds were obtained for a minimum of 5,000 views per object. We performed the data collection process for 7 different objects. 3 of these items were custom 3D models and include many concave sections and holes. 3 other objects were constructed from various household objects. A toy ViewMaster was used for testing the system, but not for training. After training, ShapeNet objects were loaded into a gazebo simulation, and a simulated stereo camera obtained data, similar to the previous data collection method. The next best view for various initial views of these objects was then calculated with our trained model, and our tests showed that the use of topological features can be used for the next best view through deep reinforcement learning. The collected data, the robotic manipulator design, and all necessary source code can be found on our GitHub page.